radical and rational functions. The first two lessons all about radical functions. So, and you guys have seen radical functions before. The first one we're going to look at, yeah, it's radical, is the square root of x. Okay, what's something you guys already know about the domain on the square root of x? Greater than 0 or equal to. You can't put a negative number underneath the square root. It's just not possible. So let's explore that further. If we were to try and take the square root of -4, what would we get? An error. Okay, so it does not exist. Maybe I'll move this up just a little bit.
Bless you.
Is that a sneeze or a yawn?
It's a sneeze.
Very sick.
Yeah, I'm pretty clogged
Oh,
up.
I did not mean to do that.
Hey, what about if we sub -1 into our x? So we get the square root of -1. It does not exist. Okay, square root of 0? 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And the square root of 16 is 4. So all we have to do now is plot these points and we'll have the graph of the radical function x. Okay, at x equals -4 and -1, nothing happens there. But when x is 0, y is 0. So let's put a point here. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. And when x is 16, y is 4. So just by taking a few ordered pairs, we've come up with the base radical function of x. We've already talked about it a little bit, but explain why the domain of the function is not the set of all real numbers. Good, you can't have a negative square root. Therefore, any value of x that is negative will be undefined. What is the domain of the radical function of x, the square root of x? Who's mumbling out there?
Chris.
What is it? Chris? Greater than or equal to 0. Perfect, thank you. You got it. And maybe I'll put that in proper form. Okay, and of the numbers that are greater than or equal to 0, they're real. What is the range of the square root of x? The same, except for we're using y. Okay, y is greater than or equal to 0. Perfect.
Wait, but can't you, like, isn't there this, like, the thing where, like, if you take the square root of 4, like, it'll still be -2?
So the square root,
Because, like, -2 squared is 4.
so you could have, like if you were to go -2 squared, you would get 4.
Yeah.
But you can't get that the square, well you could get the square root of 4 if you take the positive negative is equal to positive -2. But the number underneath is still positive.
Okay.
Okay?
Yep.
You can't take negative square roots. So I'm sure you guys are going to be excited about the next bit. We're basically just reviewing transformations.
Yes.
So hopefully this next bit goes smoothly because we've done a lot of it. And you're going to see transformations come up over and over and over and over again this year. So let's just review. If we were to compare the graph of y equals the square root of x to the transformed graph, guys, y minus k equals a times the square root of b times x minus h, we have all sorts of transformations that could happen. So if y is replaced, for example, we started with y equals the square root of x, and we ended up with y equals the square root of x plus k, that k is telling us what? Moving up or down? Okay, that's what a vertical translation is. Okay, we'd be moving up or down. A horizontal translation, that's the h parameter. X will be replaced with x minus h. The h will move the graph left or right. If h is positive, we move right. If h is negative, we move left. We also looked at reflections in the x-axis and y-axis. So for example, if we went from f of x to y equals negative f of x, okay, the y coordinates are going to change, which means we reflect in the x-axis. For the reflection in the y-axis, the x values change sign, so we're reflecting in the y-axis. We also looked at inverse, which is the inverse functions, which is the reflection in y equals x, so your x and y points change. And then we had vertical stretches and horizontal stretches. So if we see the graph y equals a times f of x, the value, the multiple in front, or leading coefficient, that will be a vertical stretch factor. And if we're looking at horizontal stretches, we'll see the function with a stretch factor on the inside, so it's going to be multiplied by the x. What do we have to remember about that b value? Say it was f of 3x right here. What would be the actual horizontal stretch? Reciprocal, so 1 over 3. Good. So another reminder about transformations is if you are ever drawing a function after a transformation, you have to follow the order of stretches first, reflections second, and translations last. If you do point mapping, it shouldn't matter. You just take a point, apply the transformations, and move it. You don't have to do 3 steps. Alright, so let's compare the graph of the square root of x. We're going to then make a rough sketch of the graph y minus 4 equals the square root of x plus 2. And we're going to state the domain and range of the new function. So I always like to rearrange for y equals. We'll get y equals the square root of x plus 2 plus 4. If we are comparing to y equals the square root of x, what's happening? What transformations are occurring from here to here? Okay, we're going left 2. And what's the 4 telling us? We're going up 4. So left is a horizontal translation, and moving up is a vertical translation. If we were to do point mapping, our xy would go to x minus 2, because we're going left 2 spaces, and y would go to y plus 4, because we're going up. Can you guys find an obvious point on that graph? No?
No, that 0.
Yeah, the origin, 0, 0. So let's use our point mapping to move that. So 0, 0 goes to 0 minus 2, so negative 2, and 0 plus 4 is 4. So we're moving left 2 spaces and up 4 spaces. And our point has been moved to negative 2, 4. And the rest of the graph, it hasn't been stretched or reflected, so it takes on the same shape. So if we were to describe the domain and range of our new transformed radical function, what would it be? X is greater than or equal to negative 2. And our range, we've gone up 4 spaces, so now it's y is greater than or equal to 4. We're going to be doing the same thing with a few transformations. So we're going to figure out what were the transformations and then describe the domain and range of the new function. So again, if we're comparing to y equals the square root of x, let's just convert this so it's a y equals. We get y equals half of the square root of negative x. What transformations are happening? Okay, what does the half tell us? Xander? Sorry, got you in your mouth as well. So what does the half tell us?
That it's a vertical.
Yeah, by a half. Awesome. And what does this negative x tell us? How about Brett? What does this negative x tell us?
Reflection.
Okay, over what axis? If x is changing sign, yeah, the y-axis. So if we were to do a point mapping, okay, we'd have x would be changing sign to negative x, and our y would be stretched by half, so we have half of y. So if we subbed in 0, the point 0, 0 into here, we'd have 0, 0, negative 0 is still 0, and then we have half of the y coordinates. So instead of it being this tall, it's going to be half tall. But what do I have to remember?
Reflection.
Reflection. So it's half tall, but flipping over the y-axis. Okay, all the y coordinates are shrunk by half. So now that we've drawn our picture, we can describe the domain. This time x will be less than or equal to 0, because it's been reflected over the y-axis. And our range will be the same. It's still greater than or equal to 0. Alright, B for C. Let's rearrange this for y equals. We got y equals negative square root of x minus 5. What are the transformations? We're reflecting over the x-axis because y will change. And we're going down 5 units, which will be a vertical translation. So our point mapping, x, y, will go to reflection over the x-axis. So x will stay the same, but y is going to have a change in sign, so we have negative y. And then we're moving down 5 spaces, so we also subtract 5. So reflection over x-axis, that comes first, and then we translate. So if I were to reflect over the x-axis, this would be my shape, but then I've got to move this down 1, 2, 3, 4, 5 spaces. So there's my new function. Domain stayed the same. X is greater than or equal to 0. And our range will be y is less than or equal to negative 5. Bruce, help me out with the last one. What kind of transformations are we seeing?
A vertical stretch by a factor of 3.
You got it. What else?
Horizontal stretch by a factor of 1/2.
Yep.
And then right 1.
Okay, you're very close. What do we always have to remember when we have a coefficient on the x? You must factor it. So you have to factor the 2 of both terms. And Bruce, you nailed it with the reciprocal, right? If it says a 2 here, the stretch factor is a half. But you have to factor it out of both terms, which means you're actually moving right, not 1 space, but half a space.
Okay.
Okay? So right by half of a unit. So let's just take a look at our origin. And if you want, we can do some point mapping as well. So xy goes to, we're going right by half a unit, and there's a horizontal stretch of a half, so it will be half of x plus a half. Don't need a bracket quite yet. All right. And what's happening in y, there's a vertical stretch by 3. So there's no reflections, we don't have to worry about changing the orientation, we just have to move right by a half, and all the x values will be compressed, they're getting, I guess, skinnier. Okay, and then the y values are being stretched by a value of 3, so they're going to be getting taller. So we're getting skinnier and taller, we're moving right by a half. So 0, 0 will go to 1/2. And then we're going to get skinnier and taller. And just keep in mind these are rough sketches, not accurate sketches. The domain will be x is greater than or equal to 1/2. And the range will be y is greater than or equal to 0. Alright, and the last question is really similar to a type of question you guys saw in your exponents and logarithms unit test. Except for you're given a picture and you had to decide what the values of a and h were. Here we're going to be given the graph of y equals a times the square root of bx. And we've already talked about a is your vertical stretch factor, b is your horizontal stretch factor. We have to describe the domain and range if they're either positive or negative. So if both a and b are positive, greater than 0, okay, a and b are positive, we'll have a graph that could be described, say, something like this, which would look like this. No matter what your a and b are, if they're positive, they're going to take on that general shape. So the domain, I'm just going to write it shorthand, x is greater than or equal to 0. Bless you. And the range is y is greater than or equal to 0. Next example, they're saying that a is negative. So just for simplicity, I'll give the example of y equals negative square root of x. What kind of reflection are we seeing? Reflection over x-axis. So if we were to draw a picture, this is our original, our base, y equals the square root of x. If we have a reflection over the x-axis, it'll look like this. So our domain didn't change, x is still greater than or equal to 0, but our range will now be less than or equal to 0. Okay, what happens if a is positive and b is negative? For simplicity, y could equal the square root of negative x. So where are we reflecting? The y-axis. So if we're reflecting over the y-axis, your graph will generally look like that. So your domain switched, it's now less than or equal to 0. And your range stayed the same at y is greater than or equal to 0. Feel free to bring it over if you want. Now what happens if both a and b are negative? So for simplicity, a base graph could be negative square root of negative x. What did you say? Yeah, there's a reflection over both the x and y axis. So then our graph would reflect, if we started here, would reflect over here and then down here. The graph would look like that. Domain x is less than or equal to 0, and our range y is less than or equal to 0. So that's a basic